by kicking off just really quickly. Andy and I are just going to share some of the insights from the last workshop that we had. So thank you again for everybody that joined that last session. We're going to keep today to an hour maximum. So yeah, we'll make sure that we're really timely, and I really appreciate your time and your input. So, you know, in terms of the last workshop, we were looking to get feedback and insights from people in the wine community about what features of a vineyard. Sorry, I'm just trying to let people in. Were most important to them, with the objective to use this feedback to inform a conceptual data model that we can build rough consensus around. So, so we've gone through these three boards, and sorry, I'm just getting some. We've gone through these three boards that both the in-person and online groups created, and we've also had some, there was some really helpful feedback from the community about essentially ensuring that there's so many things that you could map in vineyards, and like just because you can map it doesn't mean that we necessarily should map it, and really just a couple of people sort of reiterated that we really need to focus on ensuring that we get those core elements of vineyards properly thought through. Those
system work, Lee. We'll just leave this going, okay?
So if everybody doesn't mind, sorry, just muting your microphones if that's okay. So so there were four features that were consistently identified as core things, and this came up from every one of the three groups. So they were vineyards, blocks, vine rows, and vines. We'll come into these in a session, but one of the other things we did in the last workshop was to have an initial pass at defining what these core features were. And subsequently, we've had some really good feedback from people, which is really appreciated, about how they would define these core features. So Andy's going to kind of share these initial definitions that have come from the group. And again, as I said at the beginning, our aim is to build rough consensus that these are along the right lines at this stage. So if you've got any input and you don't think that these definitions are quite right, please feel free to add any notes in chat or ask a question at the end of the session. So, but I'll pass over to Andy now to talk through those initial definitions.
Thanks, Holly. I think the other thing to note is in building this model, we're not here to build the perfect vineyard map as well. We're essentially trying to build those foundational pieces for technologies and other concepts to be built upon. So the devil in the detail can come later. This is just these foundational blocks. So Ollie, if you want to move through to the next slide. We're looking at, so again, these aren't from Ollie and myself, but these are from the community, these definitions, where a vineyard is a plantation of grape-bearing vines, typically being made up of a collection of blocks owned or cropped by the same company of grape growers. So that is the foundational larger part of a vineyard. From a block perspective, it's an area or areas, if it's not contiguous areas of vineyards, planted with vines, which is managed as the basic operational unit by the grape grower. So that's that foundational management block, or management unit within a vineyard. Within that block, you then have sub-blocks, which is a region within a block that is considered as a specific area within the block by the grape grower. So that comes down to some of those sub-management things, which could be related to any number of things, but as an example, it could be different rootstocks, different irrigation, any number of ways that you are actually breaking down that one management block as the block itself. Sorry if I keep repeating these words. The next step down as we work through this hierarchy is a vine row, as an arrangement of vines laid out in a linear or curvilinear pattern with defined row ends such that they can be accessed by the headlands. I think the interesting thing to note in here is whilst many traditional are defined by often end posts, that's not all vineyard types. So that's why we're keeping it without posts mentioned within a vine row. If we move on to the next one, Ollie. And so that brings us on to the definition of a headland, which you can see actually sits within the vineyard, not within the vine row itself. So that's an area of land without vines that exists at the end of vine rows, managed in a way to facilitate access. The way that these are positioned is actually really important as to where they sort of form as part of it. Likewise, the mid-row, which is also a function of the block, much like the vine row. So it's an area of land without vines that exists between the vine rows, managed in a way to facilitate access.
Great, thank you very much there, Andy. So just going on from that, like we said, our proposal is to keep the conceptual data model focused on those 4 key components down the left-hand side, but to enable it to be extendable by adding specific attributes to those core components. So for example, with vineyards, some of the things that were put up on lots and lots of the sticky notes were things like being able to map where access points are onto a vineyard, where the roads or headlands, as Andy just defined, come in, other vegetation zones, bit like buildings, sheds, and also hazards. And from a vine road perspective, you might be adding attributes such as the posts, the wires, and also there was feedback about the importance of being able to add attributes about the trellis tide and also the canopy. And just again, there will be people that will want to extend the vine model who are very focused on things like the genetics of the vine. So, you know, they might be interested in some of that metadata around like the variety and the clone. So as everybody started to stick those sticky notes up on those big images that we did in workshop 2, it was really clear that there was also a separate kind of infrastructure layer that mapped against those core features. So broadly, it was things like IoT sensors. So they might well be positioned at specific points along a vine row or actually linked into a specific vine. There was also kind of equipment like a frost fan that might be on a certain part of a vineyard, and also mapping across and overlaying the whole irrigation infrastructure. So that was quite extensive. So it might be, you know, dripper lines that go along vine rows. It might be things like that are hazards like submains, also things that are points such as solenoids and flow meters. So yeah, we just again are, as we're working through this process, ensuring that that infrastructure layer has the ability to be mapped and overlaid against all those core components. And also there was a number of posts that were put up about, you know, again, how spatial imagery maps against the core features of vineyards, and whether, you know, people were noting that spatial imagery and data often comes either top down or it's laterally created. And turning this remotely sensed imagery into tabulated data against these individual sort of vines and rows and blocks is going to be something that Shay and Hans are going to be touching on in their next presentation. So hopefully this is a good moment to pass on to both of them. So Hans and Shay, over to you. Thank you so much for making the time to present. And Hans and Shay, as you'll see, are going to be kind of taking Hans bridges the worlds of mining and viticulture, and they're going to be sharing about like their learnings in their previous industry and how it can apply to grape growing. So thank you so much for making the time, and over to you.
Okay, thanks Ollie. So yeah, what I'm going to do is take you on a bit of a journey about what we've learnt in the mining industry over the last, say, 30 to 40 years. And hopefully this will save a bit of relearning for viticulture. So I'll just start off with, this is sort of a summary of the things that we've come to in the mining industry. So in all cases now, all data that is collected for mining companies goes through relational databases. This is not even really discussed anymore. It's just that's what happens. Mining companies invest a lot of money into their data because it really is the asset that they have until they can extract metal from the ground. So they spend a lot of money making sure that the data is looked after and is secure and is correct. But data management is a speciality in the mining industry. So you've got GIS people who are distinct from data managers, who are distinct from data scientists. They're very, very distinct, different specialities, and very rarely do people cross across those boundaries. There was some discussion in the last session about different file formats, and what we've ended up with in the mining industry is that most of the time we're doing file transfers via CSV, because every piece of software can export it, every piece of software can import it. It's a simple format to use. It doesn't require any special programming skills to be able to read and create those file types. So there's a lot of talk about APIs and XML formats and proprietary software formats, but at the end of the day, all of those things are complex. So if we're trying to do this as simply as possible, then the CSV is the way to go. Quality control of the data, everything that goes through any mining company's databases always has to have quality control on it, and it's in fact legislated via various codes that you can't release results unless it's all been quality controlled. And finally, extracting the full value of all of the data that's collected. So you might not think that a piece of data is very valuable, but you've collected it, so you should really store it, because you never know when you let data scientists have a go at looking at your data. They pull out insights from things that you would never expect would occur. So yeah, try and make sure that we don't exclude things that we think aren't important, because they may well be further down the track. So our basic flow for dealing with drill holes in the mining industry. We go out, we drill a hole. From that hole, we collect the cuttings from the hole as samples. And then on those samples, we do a whole lot of different things to it. I've only got 2 examples here, but there could be a range of 50 different things that go on. So one of the things that we do is we do the chemistry of the samples, and we also do some visual logging, and then we might hit it with a whole lot of sensors. So it could be hyperspectral, field portable XRF, XRD. You think of it, we've probably done it. And then once we get all of that data, we then combine it through a database, and then we start doing things to model it and analyze it. So basically in the drilling data, we create drill hole sections, which then get converted into drill block models, which is like a collection of 3-dimensional blocks, and each block is given a set of attributes. And these are, they're creed data. Basically, it's like a 3-dimensional grid. From there, we can calculate our resources. So this is grades and tonnages of the metal that's in the ground. And from that, we develop mine plans. So how do we go about doing all of this? So we collect a whole lot of raw data, which are the things that we're showing here. So field logging data, laboratory results, various sensors and images. And all of these things are great by themselves, you know, sort of useful data, but what we really want to do with them is go and turn them into useful things. We want to turn them into reports that we can read. We want to give them to machine learning algorithms so that we can extract insights. We want to plot things up in GIS. We want to be able to model things in 3D using software. And we also want to create dashboards. And the flow that happens in every case is that everything flows in and out of a database so that we can combine data together, because field logging without assays isn't really useful. Looking at hyperspectral without knowing what the field logging and the chemistry isn't useful. And the images, we have to take the data that's in the images and turn them into tabulated data sets. So this is, if you've got images, so we stick cameras down drill holes and we want to extract the lineations within those drill holes. And to do something useful with it, what we have to actually do is go and turn the lineations that we see in an image and turn it into a tabulated value. So it's a number. How thick is it? What's the angle of it? How deep is it? And then from that, we can plot those things up in 3 dimensions. So everything goes through a database. There's very rare exceptions, and everything is stored here. It's secure and it's there for perpetuity. Now, this is just a little diagram showing we've got lots of raw data, and raw data isn't information. What we want to get out of our raw data is to extract information. So to get the information out of our raw data, we need to store it, we need to validate it, we need to sort it. And then from there, we can then push it out to things that we can model and analyze. And then from there, we can gain insights and we have information. So just a bit of an evolution of the data through time. So back in the early pre-1990s, everything was done by hand. So you would receive assay files from the lab as a typed up piece of paper, which someone would then hand draw onto a section. And then you go and drill another hole and you would have to go and then redraw your section. And sometimes it all got a big mess and you'd have to start from scratch again. And the data is not very secure in that way because it's all just written on pieces of paper. So if you lost a piece of paper or a section got destroyed, then your data isn't secured. Then into the 1990s, computers started coming into use in mining companies. So Excel started being used as a repository, and it's still widely used today in some of the smaller companies. Everyone's starting to move away from that now. Folder structures were considered a database. So you have your folder structure in Windows Explorer and you go and stick all your files in there, and that was considered your database. And it wasn't very good because the files could be copied. People would have their own copies of various things, and there was multiple copies of the same data, which is a terrible setup to have. So when we got towards the end of the 1990s, companies started to realize that we needed to do something better with our data. So Sybase and then SQL Server started to appear. So there was companies started creating databases using or with interfaces using those backends. And what happened in the early 2000s was that all the software companies who had previously had their data locked away in proprietary formats realized that this wasn't really a good idea, because what you were doing, you were locking people into your software, but then they were going, well, we don't actually want to use just your software, we want to use a range of software. So basically all the software providers decided that we better try and make these things interoperable between each other. So what I mean by that is that if you were an Esri user, you had all your data locked away in shapefiles, and if you were a MapInfo user, it became quite difficult to import those sorts of things, and vice versa, you couldn't import a tab file into Esri. But by the early 2000s, that had sort of been overcome, and Things like QGIS were coming out that would read various different file formats. And then into the 2010s, cloud hosting of databases started occurring. There was a lot more GIS being centrally stored in databases rather than being stored in the proprietary file formats like the Esri shapefile. There was a lot more new sensors being thrown at the data. So we were collecting a whole lot of new pieces of data, and our databases were getting a lot bigger around that time. Yeah, so by the end of the 2010s, a lot of the mining companies have now got cloud-hosted databases. We're collecting a whole lot of new and interesting data that we didn't earlier, and now it's all being stored, and we're gaining insights from that using data science. Now, going forward, we don't know what we're going to see in the future, but the things that are just starting to happen now is automated logging of core. So rather than geologists looking at the core first and then us making some artificial intelligence type extractions of information from it, what we're looking at now is using all of our different sorts of sensor data to go and make an automated log of the core, and then focusing geologists on looking at particular things that are interesting in that. So let's not spend time on the mundane things that we already know about. Let's go and look at the interesting things. As I've said, cloud-hosted systems are now becoming the norm. In the past, for a company to set up a SQL Server database, you needed a $50,000 server, $20,000 worth of licensing. You had to have other IT infrastructure around it. Now you can get a full SQL Server type system in the cloud for a low monthly cost for the hosting of that. And when I say low, we're talking about hundreds of dollars or less than $100 a month, depending on the size of your database. And the other thing that's really happening now is that geologists are not going to be out there being data collection monkeys, which has been happening a lot. You know, you spend your 5 years at uni and you go out, sit on a drill rig to collect data. Now what's going to happen in the future is that we're going to use the sensors to collect that data, and geologists are going to spend a lot more time analysing the data and extracting information from data rather than just collecting it and let the machines do the collection of it. So this is a little cross section showing our drill rig sitting at the surface, and it's drilling some holes. Now, as we drill down holes, we take each of these little squares as a sample, and we collect a whole lot of attributes against that particular sample. And then from that, we can then model up something, which is our ore body, which is this orange blobby thing here. So this might be where gold is greater than the 1 part per million cutoff required to create a mine. And now this is where it gets interesting with viticulture, because the thing that I see is very similar between what we're doing in drilling holes and vines is that our drill holes look suspiciously similar to rows of vines, where instead of our samples, we've now got a vine with an area of influence around it. So between each vine and between each row, you have an area of influence that affects that vine. So maybe one way that we could think about this is use the learnings from the drilling databases and apply them to vineyards using the vine as the sample. We treat our rows like drill holes. And next slide, move on. There we go. So on the left here, we've got our geology data model. This is a fairly standard sort of setup. It's obviously not all of the tables, it's just a short selection. So in geology, we have projects because a company will be working on multiple different projects and prospects at the same time. We have collars. So a collar is where we start our drill hole. So a drill hole is a collar. And then off our collar, we have a whole lot of attributes. So this might be, where is it? How deep is it? Where did we intersect water? Where did we intersect basement? And then against our sample, we have a whole lot of attributes as well. So this might be how big was the sample? What depth was the sample at? What type of rock was it that we were taking? And what was the shortwave infrared response on that sample? And then we have some specific tables for various things, like the chemistry lives in a very specific table format because we want to carry metadata across, and the same with field portable XRF. And the analogy here is on the right, where we've got a block is sort of equivalent to a project, a row is equivalent to a hole, and a vine is equivalent to a sample. And so using a format like this, we're then allowing ourselves to collect whatever attributes we can think of against a particular item. So we're not going to lock people in and say, you must collect a particular item. And we know that every vineyard is probably going to be ever so slightly different. So we're not going to have the same attributes being collected everywhere. So we need to think about flexibility in the data model. So one example of that is if we use a flat data structure like this, where we have sample and we have all of these columns that are specifically created, then you end up with very, very wide tables. And if someone comes up with a new attribute that they want to collect, they then have to change the data structure to make that fit. So I think what we probably should be thinking about is using a normalized data structure where you have multiple attributes against a particular item, and then you can collect those values against that. And that gives you the flexibility. So probably where you'll probably end up is with a model where you have some fields that are going to be mandatory type things, like where is my vine, where is the start of my row, what direction is it? But then all of the other things that you're not really sure what they're going to be, the Internet of Things sensors and all those types of items, you put them into a normalized structure so that you're not constrained by any of that. Now, to put this all in a bit more context for viticulture, I'm going to hand over to Hans, who I don't know how many of you know, but Hans has been a viticulturist for quite a while. But before that, in his previous life, he was a geologist in a couple of gold mines and quite an interesting iron mine. So he knows both sides of this story. So over to you, Hans.
Thanks, Shay. We'll see if we can make a smooth transition between screens. Right. Thanks, Ollie. So I guess a key point I want to make here about the data model is that we're not necessarily talking about a financial or a business management software data system database that we see a lot in agriculture and ag tech. Like a data model really is focused on the technical data and the management of that technical data. So that's both for geology, as Shay was just saying, in terms of understanding aspects of the rocks that you're drilling into, and similarly for the viticultural data model, the aspects of vine-based measures, which will help you manage a vineyard. But why individual vine? And I suppose that many of you who know me know that I've been talking about this for a long time. I guess from my thought is that it's something that from a data manager's point of view to a vineyard manager's point of view, it's got to be relatable. So the data manager is looking for something to attribute the data to. And in a vineyard, I mean, like the vine spacing we've got, the trunk position, inherently you say is that area of influence. It makes sense to me anyway. But also, I think for vineyard managers, it makes sense in terms of if you're trying to manage something or manage a problem or have a unit of measure, the vine is something that's inherently tangible to a vineyard manager. There's a problem out in the block. If you can be told the row, how many meters down the row, how many panels down the row, or which vine number it is, you can actually go straight there without having GPS with you or something. You just do the vine counts, get to that vine, and you know that you're at the vine you want to look at and see what the problem is. And so therefore, in the viticulture data model, what sort of inputs could we have? Well, there could be data collected through scouting, such as your phenological stage, your bunch counts for crop estimates, pruning weights, number of nodes retained after pruning, things such as top-down that Ollie was talking about, NDVI and PCD imagery, or side-on collection from sensors or other forms of imagery. And one from the first session that we looked at was the GoPro imagery being collected by Bitwise Agronomy in their first session. And what would be some of the outputs here? So it could be pumping out seasonal reports and making comparisons, your crop estimate information, statistical insights from the vineyard, and identification of outliers and the likes. Of course, you want to be pushing that data out into, or it may be needed to be input into software. With the crop estimates in particular, I'd be thinking of something such as Grape Forecaster, or if you're wanting to look at outliers or your observations spatially, maybe into QGIS or Esri. But importantly, this is again where this database fits in. We're talking about this collection of data, managing the data through a database, and then pumping it out to your outputs be it for your reporting dashboards or the likes. It's important that it is linked by a database to maintain the integrity of the data and to provide a single source of truth. And then an important point that I think is that as a producer, it enables you to manage the data on your own terms and then also use it for your own purpose. So be it either yourself entering this data into a database or having a data manager that's assisting with this. The data, it's your database, and then you can push that out into the software specific that you're using. And so how does this look in practice? So at Penley Estate, over the last 3 years, I've been working towards creating, I guess, one of these vineyard data models. So we'll start off with a top-down aerial image, and we can see all the typical features of a vineyard that we've been discussing. So in session 2, so on the next image here, we have the block boundary. We have a couple of points here, buildings, trees, the pump shed, headland, and the access road over here, as well as areas of vegetation through there. So we'll go back and compare that. Again, the same aerial image with that overlaid. So we can see, well, the vegetation could have been a bit closer, but anyway, the buildings are quite good, the location of the trees, pump shed. But what I've also got in here is then within this sub-block area is every individual row. And then the next step I took was to survey every individual vine. And that's what this looks like. And then within that image, each vine represented by a point is coloured according to a value for NDVI. So a collection of all the vine-only pixels that were within an individual vine's sphere area of influence, then averaging that up to get a value for NDVI. And one of the things here in thinking about this, and actually just in preparing this presentation with Shay, is that this understanding that agriculture really is that 2020 beyond time in terms of the sensors we've got, the computer vision that's just around the corner to being used more broadly. So we're really at the bleeding edge of technology. But when it sort of comes to the way that we're managing our data, yeah, we're a little bit stuck in the 90s. And I guess, what do I mean by this? So again, going back to the image I had before, I've got an individual vine marked here by that red point down here. And then I've got all the attributes associated with that. So the row number in which that vine is, row 35, it's vine number 30, presumably from the north end. the block name, the variety, and then that its unique value of NDVI. But what's wrong with this image? And it's all those things that Shay spoke about earlier. It's that potential for duplication of data. The data is coming out of, is stored in a file folder structure. It's being produced by extracting data off a raster image. It's then been put into CSV, and now it's sitting there in QGIS. So we've got duplication all the way down the line as well. So if I make a change to one of the data sets, it's not inherently going to be changed all the way through. And importantly, I guess in this example, it shows that it can be done, and the importance of, I guess, what this exercise is all about in developing a consistent vineyard data model. But what else? I guess I'm often challenged on, well, what are the uses of managing to this level? Like I was looking at NDVI in that previous example, but what else could you do? So I just had a bit of a think about it, and I know there's going to be a lot more things that can be done, but things such as pest damage, like let's think about snail damage. I'm pretty sure you'd be able to manage or measure that at some early stage in the season. And if you're working in a database, you may be able to input that in and look at that over several seasons and go, well, is that pattern consistent? And then you can start associating it with other things like why are snails occurring in certain areas? And therefore you can become a lot more effective in managing that, or more efficient in managing that. Similarly, I think as virus is a really good example in terms of this. I've seen footage of drones flying down rows and then identifying leaves which are showing these virus symptoms. So again, what do you allocate that to? If you can allocate that to a vine, a database would allow you to track that over time. And then you could also see whether that's spreading. Virus often has, or virus have insect vectors, and then you could see your vineyard and see if it's spreading. You also keep, and so that's sort of looking at that next point there where I've got longer term trends of monitoring vine health. But similarly, if you go out, and there's a lot of talk in the industry now with managing Utica and the likes of roguing vines, and so having this continual rejuvenation of your vineyard. So right, if you've then taken out and reworked a vine, well, how are you in a large vineyard, how will you keep track of when you did that? When is it the 3 years up when you can then cut that umbilical cord from the mother vine if you've layered a replacement vine from the one next to it? Well, this is all things you have triggers in your database to give you a reminder. Now it's time to take care of that. And that might be an example of something like a threshold. So thresholds on NDVI, if certain vines fall below a certain value or something, you may have a trigger, or there may be AI insights coming in from that. So working in a database environment and having validated data can help with starting to look at things like you doing multivariate statistics. I saw that Shay had in there as well the idea of self-organizing maps. So looking at these associations which aren't necessarily intuitive, and I know in the mining industry a lot of that's being used more and more, these vague elements that no one ever paid attention to, and now actually showing these associations which can indicate bigger things in terms of ore deposits. Often I see images of deterioration or engineered variability due to irrigation or lack of irrigation. So down a vine row, the vines may physically, you can actually see it on the aerial image getting smaller because the water isn't getting down to the end of the dripper lines. Well, I know that again, there's research being done using LiDAR and getting these actual metrics on vine size. So if you could map this out and have a metric on what is the typical vine size, and potentially even for an individual vine year on year, if you're seeing this deterioration in irrigation, you can have thresholds again, which can trigger an alert, or you can actually see if there's been a failure in irrigation and the vine hasn't made expectation, you can actually have a physical number potentially on that. And numbers is something that I like. So as a geologist, geology teams often manage the data sets for mining companies, and having large data sets allows you to do pretty cool things. You can start getting into the world of statistics and looking for trends and really understanding what's going out in the field, because the data is reflecting what's happening in the real world. So again, I research being done in autonomously collecting pruning weights. Well, could we get that for every vine? You could have basically data on your whole vineyard's vine balance status, or if it's node count. So you can finally get really good comprehensive QA/QC on the quality of your pruning job, rather than just going out there as a vineyard manager and walking the rows and seeing how they perform from the vines that you could get to, and doing some stab in the dark sort of counts. Next thing as well is in managing variable rate applications. And I've got here variable rate pruning, but it could also be things where we're embarking on variable rate spraying, variable rate applications, or segmented applications of compost and mulches, which sort of leads into the next image and why I sort of like this concept of the working at the individual vine level. I think it's a level where you can scale down to the individual vine, but you can also scale up from there. And so it's one of the concepts, or one of the examples in the first session was that of linear referencing. So just playing around with the data in this image, I've been able to literally join the dots and to create this sort of linear reference map of based on NWI. And that's the sort of thing where you could have an base applications of compost, mulch, or whatever it may be, variable rate spraying based on those linear references, and feed that into units which can switch on and switch off. So again, just a few thoughts I've had on potential users and the main uses. And like I've got here 4 main uses, but it's, the uses could be anything really. But for my thinking, you're looking at managers maybe looking for efficiencies, quantifying issues, or quality control process, like I just mentioned, in looking at how the pruning numbers look. Agronomists and consultants, I think I see real potential there. Agronomists who are time poor, managing multiple properties, potentially across multiple regions. If they can focus their attention and plan visits before getting to a block, because they've got all this feedback from all this data that they're getting, the use of time is going to be a lot more efficient and more effective. And similarly, service providers and the use of robots, sensors mounted to robots, or just sensors mounted on traditional tractors, or they're going around the vineyards collecting a lot of data. Well, this data needs to be managed, and so service providers, I see, will need to use databases so they can really simply push that data out to their users as well, to their clients. And that's where you get onto also, with the scale of data being collected, concepts such as edge computing. And so I'm going to run through a bit of a hypothetical scenario now. And so I'm fortunate enough to be involved in a pilot with Bitwise Agronomy and test them out and play around with some of their data, or the data being collected at Penley Estate. So here we've got an image collected off a GoPro camera. So it's just a single image. We've got the post in the middle there and 2 vines. One on the left has been retrained after cutting low from Utipa, and the one on the right has been somewhat less fortunate and hasn't really come back from that operation. So we've gone along, and it's this thing about, Shay mentioned it before, extracting tabulated data from images. So by running down this row, a single row with the GoPro camera on, we've been able to, or Bitwise Agronomy have been able to extract the following data. So for every vine, I've now got a node count. Now I'm beholden to the quality of this data because I pruned all these vines, and so you can cast judgment on me later. But what we can see there is we've put bounds of standard deviations, and looking specifically for what was the average count, buds per vine? Was that sort of what I was aiming for? And then are there any outliers to that? And this is where I can go to this hypothetical scenario of an agronomist or consultant coming down to visit me at Penley Estate in Coonawarra, because this data, I can extract that as a CSV, and then I can put it into QGIS. And now I've got an image here saying, well, these outliers here, is it, potentially, let's imagine it's these 2 vines here. So these points, these vines here are coloured based on standard deviation. So before I even, I've got to go to the Barossa, I've look at Pathway, I'm based in Adelaide, and then I still want to go to Penley Estate. I haven't got a lot of time. So I'm thinking, well, what's going on here with these vines? So what I can do is get on the phone and get back onto Bitwise Agronomy and say, look, can you send me that image? So now we've we've created data from an image, but I've still got that raw data. So now I'm sitting in Adelaide, I can look at this image here and say, right, well, on the left, that first vine, it's just one that still needs a bit more vine training. So that's why it's an outlier. And the one here is dead. So I'm going to get on the phone to the vineyard manager and say, hey, look, you know, these vines in this row, vine train that one, you might need to layer from the next door vine here and replace that, or just replant a vine, and then cast your focus elsewhere for the limited time you have that you're down in Coonawarra. So just in winding up now, so our contact details are down there, and mine in particular, just because those listening and viewing today, like any thoughts that you may have on technology, data and its storage, I'll be really happy to hear and interested to hear from you. Because I can actually say today that I'm the fortunate recipient of a 2021 Nuffield Scholarship supported by One Australia to research the topic of practical data management, to provide value and insights to viticulturalists now and in the future. So yeah, look, if you've got any thoughts whatsoever, please get in touch with me. I'll be really interested to hear from you. And I'll hand back to you, Ollie.
Fantastic, lovely. Thank you, Hans, and many congratulations on getting your scholarship. And I guess I'll probably just throw to the to everybody who's joined us, if you do have a specific question for, you know, Hans or Shay, or myself or Andy, yeah, please feel free to unmute yourself and ask away. That would be great.
Ollie, it's Rob Bramley here. Hans could probably see this question coming. What both Hans and Shay have talked about is point data in terms of recognising the vine as a point. And the example that Hans gave just now was a good one in terms of where you do actually want to manage those points. But you need to remember that vineyards are planted on land, and land is continuous. And so if you want to manage some aspect of the land, then some interpolation of that data would probably be useful. For example, if you want to identify areas within the vineyard which need lime, or which might even need mulch to be applied, dare I suggest it, using platform or some other technology. So you need to, as well as managing your point data, have capacity for managing interpolated data as well. And that raises all sorts of questions about making sure that the interpolation methodology used is correct. Let's not get bogged down in that other issue now, but I just want to know how Hansen and Shay are thinking about the management and storage of that interpolated data as opposed to the point data, because I think both of them are just as important.
Yeah, I can potentially start on that one. My thoughts on that have been, again, in using GIS, so we can still sort of work in terms of our zones, so still have the raster images or the zones, and then transferring that data down to the point level. So still allocating it as a point, and then you can sort of, again, scale up from that, scaling down to the point to store it, and then scaling back out and looking at it like that. I think, and again, Shay and I have discussed in the past that there are still some pieces of data which will need to be stored in their raw format, and be that example I gave of the photo, like and edge computing potentially saying, right, from the source of collection, it may have been loaded up to a database as a point piece of data, a number, but on the GoPro, it's still stored as that image for whatever time period that may be. You got any thoughts there, Shay?
Yeah, I was just going to say, Rob, the other thing is that we are talking about point data, but as I mentioned in the earlier part of the presentation, we're talking about areas of influence around a vine. So if you take the half distance between the vine in the row and then the half distance between the rows themselves, you're actually ending up with a block around each vine. And so if you treat things at that level, that you're then taking into account the area of ground around the vine itself, and that would be one way to handle it. So I don't profess to know all of the answers, but we can, you know, we're putting out a few ideas out there that could possibly work.
Great, thank you guys. And Are there any other questions out there? Oh, well, I've got one for you, Shay. So you were just talking about, you know, you mentioned about like the useful insights that people in the mining industry have started to get when they've been kind of bringing together disparate data sets. And, you know, to kind of uncover things about your body in your example. Like, yeah, what do you actually have some examples of when that's sort of happened?
Yeah, so I do. Thanks, Ollie. So I guess this is a fairly recent thing now that the computer power has caught up, that people can now do this sort of thing. But one of the things that data scientists look at is, instead of looking at the obvious things, so if you're in a, say, a copper mine, people tend to focus on looking at copper and lead and zinc and the kind of big elements. But maybe what you need to do is look at other external sort of things that you wouldn't have thought were quite so interesting. So one example that we've seen was a gold mine that were trying to work out how to reduce the costs of their assaying to work out what was going through the mill. And what they actually did was they went and gave a whole lot of data to some data scientists, and this was all disparate data sets, not even related to the ore itself. And what they came up with was that they could estimate their gold grades based on the correlation between the wear on belts on the ball mill and the diesel usage. Because, and you think about that and you go, well, why is that? And they went back and had a look at it, and it was because the gold is hosted in quartz, which is the hardest rock in that mine. And so the diesel usage goes up in the ball mill when you have more quartz. And so it wasn't a perfect analogy for it, but it was close enough to get them into the ballpark. So just think about data that you think might not have anything to do with anything, but you might be able to find an insight from it by some strange sort of correlation between various pieces of information.
No, thank you, Shay. I just got I've seen a quick question from Tim Hans. He was just asking about, you meant there was like a slide you had like VR pruning on it as a title. He just wondered if you could elaborate any more thinking that you've had around that space.
Yeah, that probably comes specifically from a Coonawarra vineyard management cap on, where everyone thinks Coonawarra is so flat, but there's a huge amount of variability going on below the ground. So you can see this vine to vine variability, and so so working at that detailed level, it may be an enabler in terms of understanding a block to that level to prune to that level. But the other flip side of that, and why I put it in there, I guess, is for a long time there's been talk about this robotic pruning, and this is again an example what Shay just touched on there, looking at these disparate data sets. On the one hand, it's getting the job done. So there's the robotic pruner, whenever that comes to fruition, will go along and prune those vines. It'll analyse the vine, it'll assess it and say, right, how many buds were retained, and it'll treat that vine as an individual and prune it to an appropriate number of buds. What I would say is the really valuable aspect of that is the data coming off that robot. Like, let's make sure we capture that, because you're getting a visualization, so an image which you can convert to numbers of every single vine in your vineyard. And then you can actually get a quality control number, or you can, again, get a pruning weight or whatever it might be. Like, collect the data that machine has collected in its analysis and store that, because that's the sort of thing you could relate in other ways. And I think another example I've seen in the last week, and it's not in viticulture, but it's in the apple industry, where they're using chemical thinning. I don't proclaim to know a lot about it, but again, this captured my imagination in terms of variable rate management, saying that they've now got a way of on the go that they can spray the trees which are ready for this chemical shoot thinning with whatever product or whatever they do. In my mind, again, there's this real opportunity there at the individual tree level to capture this data, saying, well, which trees are they spraying at what time? Is that a pattern that's consistent throughout the seasons? What other factors are impacting that? You can start asking questions of it and becoming better in your management. So I think in the coming years, as we're, this new technology, it's not just robots or equipment that can better do a task. let's think about the what data that piece of equipment is collecting, the information of things, and let's think about ways that we can store that so we get really valuable insights to improve our management and the efficiency of management.
Bro, thank you, Hans. I'm just, I said that we would keep to our hour, so I know we've only got a couple of minutes left. So just before there's any last questions, I want to make sure that everybody's clear. You know, there's a couple of next steps that we want to make. So one of the things that we want to do is actually publish out, you know, where the conceptual data model is at this stage with the feedback we've had from everybody. We plan to basically do a couple of articles that we'll put out in the kind of greater wine industry media, so we can make sure we can, you know, we're openly sharing where we're up to now. I think that we know that the balance we're trying to find is to, even at the conceptual level, create a model which is detailed enough to be useful while not making anything that is so complex it's practically unwieldy. So it might be that we actually do come down to just actually maybe just those 4 components are the key things to actually model, but know that people will be able to extend it with what is important to them, you know, as individual players in the industry. So, but we will we'll get basically where we're up to shared widely, also with some key insights that we've learned from, you know, Emily when she's been mapping the streets, Hans and Shay that they would want to bring in from the mining industry. So we'll do that. So please look out for that and help to share it so that we've captured, you know, as many insights and feedback as we can. We'll also just publish out those initial descriptors that Andy talked through. We're planning the next one of our workshops. We've got another 3 for the back end of November, probably the 24th. And we've actually got a couple of people. We've got Tim from Think Digital and Stu Adams from Agronomy actually on the line. And they're hopefully going to have both of them over in Adelaide. And we'll try and do the next workshop in person if we can, if Stu can get over. And they're going to be really looking at things like augmented, like AR, VR in vineyards, to pick up that point around pruning that Hans was just talking about. And obviously Stu's doing some interesting work, basically creating digital twins of vineyards. So we'll step on to that. We're also going to start, we've had a first pass and we want to reach rough consensus around this conceptual model. The next stage is actually to build that out as a logical model. And I think Lindsay put in the chat about you know, working with everybody to put like a GIS ontology over some of those key points. So yeah, we'll kind of progress things over the next month, keep sharing everything with everybody. If there's anybody that you would suggest that you'd want to speak, so Hans, your last point about spraying in apple orchards, that swarm farm that we know quite well, that I think actually are going to have a swarm bot in the Coonawarra at some point this season, I hope. So again, if you want people like that to present and share like what they're doing to really kind of transform horticultural production systems, now that they, you know, are building up these like models of what an orchard looks like and building up a per tree view of an orchard. Happy to bring them in, and if that's a good suggestion, we could ask them to speak at a future event as well. So yeah, completely open for anybody in the community who wants to present. Please feel free to, or suggest anybody would like to come in. But hope that was insightful. I'm just looking at my notes. So yeah, hope that was insightful. Thank you so much for your time. We'll push out this session on YouTube so that it can be shared more widely, and look out for some follow-up emails from us shortly. And thank you so much for spending some time with us this morning. Okay, take care. And thank you so much, Hans, and congratulations again. And thank you, Shay. Take care, everybody.
Pleasure.
Thanks, all.
Thanks, Ollie.
Thanks, Ollie. Thanks, everyone.